Hello everyone, in this video I'm going to solve problem 2 of chapter 7. Determine the internal force and shear force and the bending moment in the beam at point C. So here should be normal force, internal force would be wake, and shear force and bending moment. So we need to find all the internal loading at point C and assume the support at B is a roller. Even if the problem had not told us, by looking at the picture you should be able to identify the type of support. Point C is located just to the right of the 8 kip load. So the first step is to draw the free body diagram for the entire beam. So if I draw the free body diagram, I have two supports. At A is pinned, so I have AY and AX. I have my 8 kilopound or kip. I have BY, there is no BX, and I assume there is no friction. And I have the moment here. Now we can have the dimensions. 8 feet here would be 60. So the first step is to find reaction forces of my support. So summation of forces at x equals 0. Therefore AX would be 0. I don't have any forces in x. Summation of moment. I'm going to take a moment about point A. So I get rid of AY, my unknown, and I can find BY. So force, and I assume counterclockwise to be positive. The 8 kip is creating a clockwise moment, so that would be negative. Moment arm is 8, magnitude 8. BY is creating a counterclockwise moment, so it's positive. Magnitude is BY, moment arm is 24, 16 plus 8. And I have that for the kip, which is a counterclockwise moment. There's no moment, and I don't need to multiply it by any moment R, it's just a moment. And then here I find BY to be 1 kip. Remember, the unit that we are using is kip, and the unit is consistent, so every value is reported in kip or kip foot. So summation of forces in Y equals 0. The only unknown that I have is AY. I have that negative 8 kip plus 1, the BY that I found, so AY would be 7 kip. So that's the first step, but the problem is asking for the internal loading right after that 8 kip. We want to see what's happening in this section of the beam. So we need to make a section cut in that location, so we expose our beam so we can find the internal loading. When you make a section cut, similar to the truss, you have the choice of using the right side or the left side, and you should get the same answer. So I'm just going to draw the free body diagram of both sides because it's the first problem we are solving here. Free body diagram of left and free body diagram of the right side. So here, this is our beam. I already found AX and AY. AX was 0, AY was 7 kip. 2 point C, the distance is 8 feet. I have my 8 kip right here before the point C, and here at point C I have 3 internal loading. 1 normal force, which I'm going to assume positive unless I find a negative value. That means that our assumption is incorrect, and the positive normal force is the force that creates a tension in our member. Then a shear force, VC, and a positive shear is the force that causes our member to rotate clockwise. So that's the positive shear force. And also the moment. Positive moment would be creating a upward curvature. And if I want to draw a free body diagram on the left, I have 1 kip here. I already found the reaction forces, 40 kip. Here the distance is 16 feet. And now I need to draw the internal loading. I have NC, again positive, creates a tension in the member. VC, shear force, causes the member to rotate clockwise. And MC, creating a positive curvature. And you can see that if I add these two segments, the right and the left side together, the internal loading would be canceling each other. And then I will only have external loading. That's one way to identify that your free body diagrams are correct. But for analysis, I'm gonna just choose the left side and then find the internal loading based on the left side. So summation of first forces in x direction. I don't have any forces in x, so my normal force would be 0. So in that location, I do not have any normal force. And as a matter of fact, you won't have any normal force anywhere in your beam. So summation of forces in y equals 0. Let me draw my coordinate system. So it would be meaningless if I talk about x and y without a coordinate system. 7, -8. Then I have my VC equals 0. Therefore, the value for VC is -1 kip or kilopound. Negative value indicates the direction I assumed is incorrect. So summation of moment at C, I'm going to assume counterclockwise to be positive. Here is, we are assuming counterclockwise to be positive for finding a moment value. It had nothing to do with the convention, what is positive moment at the point of cut. So the reason that we usually find the moment about point C at the cut, because we can get rid of all our loadings. So here I have MC, which is positive. Then the force 7 kilonewton, 7 kip is going to create a moment, create a negative moment. Moment arm is 8. And that's it. Because VC and also the 8 kip are acting at point C. So they don't have any moment arm. That's why we are not including our moment equation. So the moment would be 56 kip foot. So at that location, at point C, I do not have any normal force. The normal force is 0, but I have a shear force, which is parallel to the surface, and I have a moment. So on that location, I found what's happening. If I use the right side, I would get the same answer.